I'm Andreas at Stanford. I have a PhD in machine learning and computer vision. I'm currently working at NYU as a research engineer. In this video series, I'll present intermediate and advanced concepts in machine learning and how to implement them with scikit-learn. All of the material in this series is provided in the form of Jupyter Notebooks, a browser-based interactive programming environment. This video itself is recorded in a Jupyter Notebook to give you a first impression. Using the notebook allows you to run and modify the code yourself easily and experiment with the datasets we will be analyzing. Let me give you some of the highlights of what we will cover. We'll start the series with a review of the scikit-learn API and how to use supervised and unsupervised models. Here, you can see an example of using the scikit-learn API for building a classifier. The model is built using the fit method, applied with the predict method, and evaluated using the score method. We will also review how to do model evaluation using cross-validation and parameter selection using grid search, two of the most important tools when analyzing machine learning algorithms. An example result is shown here, illustrating the cross-validation performance of a kernel SVM as a function of the two parameters, C and gamma. Then, we will talk in depth about the concepts of model complexity, overfitting, and underfitting, which are illustrated here. Understanding model complexity is central to understanding machine learning and applying it successfully. We will discuss linear models, support vector machines, and random forests in detail. And we will see how the concept of model complexity manifests in each of them. Here's an example showing how changing the depth of the trees in a random forest changes the decision function on a two-dimensional, two-class classification dataset. We'll also go in depth about the pipeline module, which allows you to chain data transformations to build complex machine learning workflows, as shown in this diagram. As data you may encounter in the real world rarely is as clean as the datasets that come with scikit-learn, we will then look into some raw, real-world data and see how we need to preprocess it before we can apply machine learning models. In particular, we'll see how to deal with categorical variables in scikit-learn and possible ways to deal with missing values. Here is a snippet that we'll discuss in detail. It shows how to transform key-value data into a numeric format suitable for machine learning. We will also discuss the processing of text data, a very common data type in practice. Starting from the basics of bag-of-word representations for text data, we will build a sentiment analysis system. The system will be able to classify movie reviews from IMDb into positive and negative reviews based on the text alone. Here is an illustration that shows which words and word pairs the resulting model deemed most informative. Negative movie reviews are associated with the words with red bars, while positive reviews are associated with the words with blue bars. We end by discussing machine learning in very large datasets and the trade-offs involved in several approaches. We will discuss the partial fit interface in scikit-learn, which allows you to train a model iteratively on streaming data, as illustrated here. As an application, we will learn a sentiment analysis system on a very large database of movie reviews with over 100,000 text documents. Using the out-of-court techniques we will discuss, this dataset can be processed in a matter of seconds on a consumer laptop. This concludes the introduction. Now let's get started and dive in.